Children, let us move to the numerical part of this velocity. So first question from worksheet number 3. A body moves with uniform velocity v1 for some time and with uniform velocity v2 for next equal time. The average velocity is. So children, we know that average velocity can be written as total displacement to the total time taken. Total displacement to the total time taken. So average velocity let us indicate with the letter V. So total displacement means how many conditions given with a uniform velocity v1 for some time and with uniform velocity v2 for next equal time. So two different conditions. So two different conditions means, so two displacement, one is S1, the other is S2 upon time is T1 plus T2. So average velocity is taken as S1 plus S2 upon T1 plus T2. But here what is the actual condition given, children? If you observe carefully, they have given that a body moves with uniform velocity for some time and with uniform velocity v2 for the next equal time. So here it is very clear that the time intervals are equal. Suppose if this t1 covers with certain time, then t2 will also be equal time. That means given condition, what has the given, children? Given that T1 is equals to T2. Let us suppose it as some T. Okay, T1 equals to T2. Let us suppose it as some T. Here velocity is given and they have also introduced you something regarding time, but nowhere they mentioned displacement. So we need to transform this displacement in terms of velocity and time. Children, earlier I told you that velocity equals to displacement by time or displacement equals to velocity into time. So displacement can be written as velocity into time. So let us check it out. Instead of displacement, what I can write is, I can replace displacement with velocity into time. S is equals to Vt. Then S1 is equals to V1 T1. S2 is equals to V2 T2. So replacing. So S1 as V1 T1 and S2 as V2 T2 by T1 plus T2. But here what is given? T1 and T2 can be taken equal. So if you substitute T1 as T, T2 should also be replaced with T only. Then this implies V is equals to, this is V1, instead of T1 I replace it with T plus V2, T2 can be replaced with the T upon T1 plus T2 means T plus T. This is nothing but what is taken common? T, children. So V1 plus V2 common is T upon T1 plus T2 is again 2T. So this T and this T gets cancelled. So what are you left with? V1 plus V2 by 2. Hence it's very clear that the average velocity V is equals to V1 plus V2 by 2. Here goes your answer. So this is your answer. Okay, children. So shall we move to next question? Question number 2. A person traveling on a straight line moves with a uniform velocity v1 for a distance x and with a uniform velocity v2 for the next equal distance. The average velocity v is given by. Okay. So children, again let us try to understand the same thing. So person traveling on what way? Straight line moves with velocity v1 some distance v2 other distance. So here the concept of velocity and distance is given, but time is not given. So earlier, as I have told you, that average velocity can be written as total displacement by total time. Total displacement to the total time. Okay. So we can write this average velocity, let us represent it with some v1, can be written as total displacement means how many conditions? 2 conditions. So s1 plus s2 upon t1 plus t2. Here they have mentioned something regarding velocity as well as something regarding the distance. Okay, but nowhere they have considered anything regarding the time. No information regarding the time. So time should be eliminated. So earlier we know that velocity equals to displacement by time. Velocity equals to displacement by time. So time can be written as displacement by velocity. So instead of time, I can replace it with displacement by velocity. So instead of time, I can replace with displacement by velocity. V equals to displacements, they have given s1 and s2. Okay, time can be written as displacement by velocity. So t equals to s by v. So t1 equals to s1 by v1 and t2 equals to s2 by v2. Isn't it, children? But what they have given here is it travels with a uniform velocity v1 for a distance x and velocity v2 for the next equal distances. Earlier case they have said times are equal. So t1 equals to t2 equals to t. But here distances are equal. So s1 is equals to s2 equals to some s. So let us replace the same. So given condition. What is the given condition, children? Given that s1 equals to s2. Let us suppose this as some s. So let us replace s1 with s as well as s2 with s. Okay, children. So now substituting in the above question, we have average velocity v can be written as instead of s1 I can replace it with s. Again instead of s2 I can replace it with s upon s1 as s, v1, again s2 as s upon v2. So after simplifying, how much you are getting? 2s upon, what is common, children? S is common. Then you are left with s taken common means 1 by v1 plus 1 by v2. So s and s gets cancelled. So clearly we have v equals to, what are you left with here? Numerator 2 upon denominator we have 1 by v1 plus 1 by v2. Isn't it, children? So 2 upon 1 by v1 plus 1 by v2. This whole term, let us bring this here, and this term let us carry to the other side. I repeat, let us exchange the terms. This to here, this complete term I will be bringing to the left side, whereas v I am taking it to the denominator. Okay, children? So let us try simplifying this. So hence the value, this part here, that means 1 by v1 plus 1 by v2 is equals to, what is left over here, children? 2 upon, bring this v to the other side. So here goes your answer. So 1 by v1 plus 1 by v2 is equals to 2 by v. So where is the correct option? So 2 by v equals to 1 by v1 plus 1 by v2. Is the concept clear, children? Okay. So moving to the third question. Consider the motion of the tip of a minute hand of a clock in 1 hour. What happens? So you know, just imagine the clock. We observe minute hand, second hand as well as hour hand in a clock. So clearly, whenever the minute hand starts moving, in 1 hour that minute hand will complete one complete revolution. So suppose this happens to be a clock. Let us imagine a clock over here. In this clock, this is 12, 6, 3 and 9. So 1, 2, 4, 5. The numbers as follow. If you observe a minute hand, only a minute hand, suppose it has started its journey at 12. After completing for 1 hour, the minute hand will make a complete revolution. So here it starts with, and again after rotating in 1 hour, it will complete its one revolution. That means again it comes back to its initial position. So what would be the displacement, children? Initial position as well as final position both remain same. So displacement would be 0. If displacement is 0, we know the formula for velocity is nothing but velocity is defined as displacement upon time. Displacement upon time. So clearly what have we considered here in this displacement? Both the initial position as well as final position remains to be same. So displacement is 0. If displacement is 0, 0 upon any time, how much is that? 0. Okay, time means that 60 seconds or 1 minute, that is 0. So what would be the correct answer? And here they have given more than one answer is possible. The displacement is 0. Yes, just now we have checked it. Okay, initial and final position remains same. So displacement is 0. Distance covered is not 0. Distance means some path it has covered. So one complete circle it has more something 2 pi r based on the radius and all. The average speed is 0. No, some distance is covered means speed will be same. Remains. Okay, some speed it has covered, it is moving with. The average velocity, what is the formula for average velocity? The total displacement by total time. Displacement was 0 for 1 minute, hence velocity, average velocity is also 0. So we have two options. What are the two options? First option, the displacement is 0, and fourth option, the average velocity is also found to be 0. Okay children, next, mark the correct statements. So what was given, children? The magnitude of the velocity of a particle is equal to its speed. Of course, children, if you observe velocity, then velocity means a vector quantity. Velocity is a vector quantity, whereas speed is a scalar quantity. So scalar means only magnitude is considered, so no need to specify any direction. But whereas velocity means velocity has magnitude as well as direction, whereas speed means it has only magnitude but no need to indicate direction. So speed having magnitude, velocity also having magnitude, but velocity extra along with speed. If you consider speed with the direction, then it happens velocity. Okay, so here magnitude, suppose a car moving with 10 meter per second, then magnitude here, velocity also, magnitude of velocity is 10 meter per second. Speed is also 10 meter per second, whereas 10 meter per second towards east, that direction also to be included to represent velocity. So the magnitude of the velocity of a particle is equals to speed. Yes, of course, both are same. This is also 10 meter per second, that is also 10 meter per second. So the first answer is true. The magnitude of velocity of a particle is equals to its speed. Moving ahead, the magnitude of average velocity in an interval is equals to average speed in that interval. No children, how is it possible? So magnitude of velocity, it may be moving forward or backward, any particular direction it can move. Okay, so but speed, you have to consider the total path length. Velocity means path length in all possible directions, positive, negative, 0, anything it can happen. So magnitude of average velocity can never be equal to, may not be equal to average speed. Can happen only if the body travels in straight line in one particular direction. Okay, so if a body moves in forward direction and comes back, or some circular direction, means here the second case may not be possible. Third question, it is possible to have a situation in which the speed of a particle is always 0, but the average speed is not equals to 0. Children, if speed is 0, how can, if the body covers certain distance, means it possesses some speed. So speed can never be 0. Okay, so wrong answer. It is possible to have a situation in which the speed of the particle is never 0, but average speed is an interval is 0. Here also, no sir, no children, it's not possible. Why? Because so particle is never 0. Some speed it has there. So if the particle is having some speed, means it covers some distance. Okay, if it covers some distance, means some sort of average speed it is having. So this is also wrong statement. This is also wrong, and this is. So only right option is the first option, that is the magnitude of velocity of a particle is equals to the speed. Okay. Next, there is a square field of side A units. Let me plot out the diagram, children. Yes, how was that? A field was given, square field it was given, some square shaped field it was given. There is a square field of side A units. What is its side given? A. So all sides are equal for a square, A respectively. An insect starts from a one corner. So what they have given me, some insect is there. Okay, some sort of insect is there that is moving here. Okay, so this starts moving started its journey from the corner, reaches diagonally opposite. Where is the diagonally opposite, children? From here it has to move this particular place, diagonally opposite, isn't it? It was like this. It has to cover this position. In a time t, this insect to move from here to here, it covers certain time t. The magnitude of its average velocity. The insect may move in any direction. Like for example, like this it can go, like this, like this, like this it can go, like this it can go. Any possible direction the insect can move. But you are asked to find the average velocity. What you are asked to find? Average velocity. So children, average velocity is nothing but total displacement by total time. Total displacement by total time. So children, what is the displacement he have? This is the initial position, this is the final position. This must be the displacement, the path length from initial to final position. Okay, that is only called as a displacement. So you need to find out this length. If you observe this diagram carefully, it forms a right angle triangle. Yes or no, children? So in this forms a right angle triangle. Then these are the sides of the right angle and this is the hypotenuse. So applying Pythagoras theorem. Applying Pythagoras theorem, let me mark it as something like O, A, O, B and OC. So we need the length of OC. Clearly OC square is equals to OA square plus AC square. Applying Pythagoras theorem. So if you want to find out OC square, what is the value of OA, children? A. So this is A square. Even AC also A square. So OC square is nothing but A square plus A square is 2A square. So if OC square is 2A square, what is OC equals to? Under root 2A square. Under root 2A square means this root over 2 is root 2. Root over A square is A. So this length, what is the length of this, children? It is clearly the length of this was found to be root 2A. So the displacement of the body was found to be root 2A. In what time have they given? Time t. Therefore, the average velocity v equals to total displacement was found to be root 2a. Total displacement was found to be root 2a and the time was given as t. Hence, v average velocity v equals to root 2a by t. So, where must be the correct answer? Here goes with. So, first answer root 2a by t. Okay, children. Next. The body starts from a point and returns back to the same point. A body starts from a point and again comes back, reaches the same point. Average velocity is 0 but not average speed. Yes. So children, if the body reaches to the same initial position, then initial position and final position both are same. If initial and final position are same, displacement is 0. So average velocity is nothing but total displacement by total time. So displacement is 0. 0 by time is 0. Hence average velocity is 0. But speed, two different lengths, initial to again coming back. Some distance it has covered. So some distance is existing. So speed is also there. So speed is not equals to 0. So if a body starts from some point and return backs to the same position like this and like this, then displacement is 0. If displacement is 0, it clearly indicates that average velocity is also equals to 0. But whereas distance is nothing but here some x distance if it covers, again the same x distance if it covers. Let us suppose an example. So 2x, some distance is there. Hence, as distance exists, speed also exists. So clearly first question is true. Average velocity is 0 but average speed is not equals to 0. Average speed is 0 but not average velocity. No. If it is true, how can it be? Both average speed and velocity are 0? No. Average velocity is 0 but average speed is not 0. Average speed and velocity depends upon the path. Of course it is clear, no? So depends upon the path means where is the path for velocity? Average velocity, there is no path because initial and final same. Okay, so no need to discuss in detail. Okay, so first option is the true option. Sixth one. A man leaves his house for a cycle ride. So a man is there. Man, let us suppose a small house building is there here. Okay, here. The man leaves his house for a cycle ride. He comes back to his house. So he goes this way and again comes to the same position. Okay, children. Well, what time has he covered? After half an hour. So leaves his house for a cycle ride. He comes back to his house after half an hour. After covering a distance of 1 kilometer. How much time, children? 1 kilometer, and the time was given as half an hour. What is the magnitude of average velocity for his ride? Children, what is the, if this person cycling, okay, this person cycling something like this, okay, goes from house and again comes back to the same initial position. Then what is the total displacement, children? Clearly total displacement is nothing but 0. So average velocity is nothing but total displacement upon total time taken. Total displacement upon total time taken. So here he goes 1 kilometer, here he goes 1 kilometer. So if you happen to calculate distance means 1 kilometer plus 1 kilometer, 2 kilometers distance. But displacement is nothing but the length between the initial and final. Here only initial position, here only final position. So displacement is 0. So 0 by time, how much they have given? 1 hour. 0 kilometers per 1 hour. So answer is 0. That's all. 0 kilometer per hour. So answer would be second option. Okay. So moving ahead, question number 8. The numerical ratio of velocity to speed of a particle is always. Children, earlier class we know that we have compared the values of distance and displacement. Distance, even the previous class also, distance means he moved ahead and here he moved ahead. X and x, 2x, whereas displacement was 0. Okay, so distance is clearly greater than 0. Some distance it has covered. So when time passes, some position he has changed, whereas displacement can never be 0. And also one more thing I can say, that distance is always positive, whereas displacement can be positive, can be negative, or equals to 0. So clearly, so distance is either greater than, if distance is positive and displacement is negative, distance is greater than displacement. If distance is positive, displacement is 0, then also distance is greater than displacement. Or in the same unique direction both are moving in the forward direction, then distance may be equals to displacement. So there is possibility that distance is either greater than or equals to displacement. Let me explain you clearly with an example. Suppose that a person is here, he moves from here to here. Number line I'll explain. Case 1, 0, 1, 2, 3, 4, 5, minus 1, minus 2, something like minus 3. Suppose example 1, a person has started his journey from here, okay, and again came back to here. Children, in this case, what was the value of distance? Distance covered equals to this length. How much is that? 4. Let us measure it in some meters. 4 meters. And again from here to here, 1, 2, 3. Totally 7 meters. And displacement was, what is the displacement, children, in the first case? Here was the initial position, here was the final position. How much is the displacement? Hardly 1 meter. Okay, what is that? 1 meter. Children, if I consider one more example, then the same number line I'll consider. 0, 1, 2, 3, 4 and 5, minus 1, minus 2, minus 3. Suppose the person has started his journey from here. He went here and again came back to the same position. Then how much would be the distance, children, in the second case? Distance is equals to here 4 meters and again coming back 4 meters. 4 plus 4 is 8 meters. Whereas displacement is 0. One more example if I would have considered then. One more example. The person has started his journey here and ended up his journey here. In that case, case 3, if you observe, how much is the distance here to here? 5 meters. Distance was found to be 5 meters. Whereas displacement, how much is the displacement, children? Initial position and final position. The length between initial and final, how much is that? 5 meters. So if you observe this, in this case, distance equals to displacement. In the first case, distance is greater than displacement. Second case also, distance is greater than displacement. So all the condition we observed that distance is either greater than displacement or equals to displacement. So distance is either greater than displacement or equals to displacement. So after simplifying this, distance is either greater than or equals to displacement. So numerical ratio of velocity to speed is, I would like to simplify the same. So what we observe was distance is greater than or equals to displacement. Let us divide this distance by time. If it is divided, here also we must divide displacement with time. Children, what is the value of distance upon time? Yes, it is speed. Greater than equals to. Displacement by time is nothing but velocity. So, speed is greater than or equals to velocity. What they are asking? Velocity to speed. So, speed you bring it here. Then it happens velocity to speed is greater than equals. Nothing is here because speed is carried. So, 1. So, clearly the ratio of velocity to speed is less than or equals to 1. Is less than or equals to 1. So, here goes your answer. equal, both less than 1 as well as equal to 1. So correct option is option number 3.